Our project is talking about cybersecurity system for self-driving car. In this presentation, we will present the problems of hacking, which lead us to search for several solutions using two different technologies to prevent the attack on smart car system. We will use the golden circuit to explain the idea of the project. At first, what is the idea of the project and what is the main problem which we try to solve it? Why? We will present the motivations which make us try to solve the problem of hacking. How? We will explain the several technologies and how we apply them in the project. Self-driving and semi-self-driving vehicles are considered a new revolutions in the automotive industry and scientific research. These vehicles are equipped with communication devices and sensors and embedded systems. This figure shows that there are many connections between RSUs and smart cars to exchange the data between smart cars and infrastructure, and this is the problem. According to these connections, it will be very easy to hack the system and it will lead to accidents. What is the idea of our project? According to several attacks which try to hack the system of the smart cars, we will make two layers to ensure that no one will be able to hack the system or manipulate the data which be exchanged between the smart cars. At first layer, we will use artificial intelligence by detecting the attack automatically using machine learning and deep learning. At the second layer, we will use the blockchain technology to support decentralization, security, and privacy.
Now I will talk about why we will present the motivation which make us try to solve the problems of hacking. Self-driving cars depend mainly on several connections like vehicle to vehicle, vehicle to infrastructure, and vehicle to anything. According to this, there are many attackers that try to steal valuable information and damage the system of the cars. Researchers and developers try to improve the network by detecting and predicting early attacks. Considered firewalls, anti-spam techniques, and antivirus are traditionally security tools, which many organizations use to protect against network attacks. But unfortunately, these tools are unable to identify new and complex attacks. Recently, network intrusion detection systems have appeared as a second line of defense to absorb the activity of network and detect intrusive events. Network intrusion detection isn't an easy mission. It's facing many problems and challenges to identify anomalies with high accuracy and efficiency.
About the artificial intelligence solution, we will use machine learning to classify 9 types of attacks. The dataset that we will use is UNSWNB15 as it is the newest, which contains 256,000 samples. The other dataset is KDD99, which becomes old and cannot detect the newest attacks. The 9 types of attacks are generic, reconnaissance, exploits, fuzzers, shellcode, backdoor, DOS, worms, and analysis. Generic is a technique that establishes against every block cipher using a hash function to cause a collision without respect to the configuration of the block cipher. Reconnaissance is an attack that collects information about a computer network to avoid its security controls. Exploits is a sequence of instructions that takes advantage of a glitch, bug, or vulnerability, causing an unintentional or unsuspected behavior on a host or a network. Fuzzers is an attack in which the attacker attempts to discover security loopholes in an application, operating system, or a network by feeding it with a massive inputting of random data to make it crash. Shell code is a malware in which the attacker penetrates a slight piece of code starting from a shell to control the hacked machine. Backdoor attack is a technique of bypassing a hidden authentication and securing unauthorized remote access to a device. DOS is an intrusion that interrupts the computer resources via memory so as to cause excessive work in order to prevent authorized requests from accessing a device. Worms is an attack in which the attacker replicates itself to spread on other computers. Often it utilizes a computer network to spread itself depending on the security failures of the target computer used to access it. Analysis is a type of variety intrusions that penetrate the web applications via ports. We will try different classification techniques in machine learning to get the best performance, like logistic regression, naive Bayes, stochastic gradient descent, k-nearest neighbors, decision tree, random forest, support vector machine, and the neural network. About the artificial intelligence solution, we will use machine learning to classify 9 types of attacks. The dataset that we will use is UNSWNB15 as it is the newest, which contains 256,000 samples. The other dataset is KDD99, which becomes old and cannot detect the newest attacks.
Second technology used blockchain using Hyperledger Fabric platform. In this part, I will talk about an introduction about the problem that leads us to use blockchain, then the motivation and why we thought of blockchain technology. Finally, I will talk about Hyperledger Fabric and timing constraints. In recent times, vehicular ad hoc networks called VANET have become a core part of intelligent transportation systems (ITS), which aim to achieve continual internet connectivity among vehicles on the road. A major feature of VANET is that it offers inter-vehicle communication and roadside units to enhance road security, local traffic flow, and the effectiveness of road traffic by offering precise and periodic data for road users. VANET offers two kinds of communications: vehicle to vehicle (V2V) and vehicle to infrastructure (V2I), onboard units (OBUs) and roadside units (RSUs). In a VANET deploy correlations using dedicated short-range communication (DSRC). The VANET has been used to improve driving safety and construct an ITS in modern cities. However, owing to the wireless characteristics, the message transmitted through the network can be observed, altered, or hacked. Since driving safety is a major part of VANET, the security and the privacy of these messages must be preserved. Therefore, our project introduces an efficient, privacy-preserving data transmission architecture that makes use of blockchain technology in cluster-based VANET. The cluster-based VANET architecture is used to achieve load balancing and minimize overhead in the network, where the clustering process is performed using the rainfall optimization algorithm ROA. The ROA-based clustering with blockchain-based data transmission called ROAC-B technique. So why blockchain? Because of decentralized structure and the dynamic topology of VANETs, the safety of vehicles, users, and information is important, and malicious node should be identified in a VANET. Vehicles exchange confidential data and the traffic is modified accordingly. The absence of authorized data leads to malevolent attacks that cause serious problems for the drivers. The messages the messages can be authorized by tracking the vehicles through a network and finding the details required. However, this compromises the security of users. Therefore, a balance should be found between authentication and the privacy. Trust management and the privacy of vehicles are challenging problems for VANET. Blockchain technology is a viable solution to overcome the security. It's a chain of blocks where each block is connected through the previous block hash value. It stores data as a transaction, which is secure, immutable, and transparent to all the network. The main advantage of blockchain are immutability, transparency, traceability, and data reliability. Why Hyperledger Fabric? First advantage, ledger type. Hyperledger Fabric is actually permission platform, so that means that it isn't for the public. Also, it's basically suited for enterprises, and it can offer the privacy they need. Thus, it comes with membership arrangement for selecting who can get an entry into the system and who can't. More so, the company itself will decide who can enter the platform. Second advantage, throughput. Hyperledger Fabric, in reality, it comes with more than 2000 TBS, so you can expect it to process more than 2000 transactions every second. Third advantage, cryptocurrency. In reality, the platform Fabric doesn't have any native token or cryptocurrency in the system. So you won't need to have cryptocurrency in order to use the platforms. However, if a company need a token based system, they can easily add it up. So they won't be forced to use any native currencies. That's a huge benefit. While we need a blockchain that deals with a secured event message without using cryptocurrency.
In this part, we will talk about system model and applicability and introduce the algorithm we used in solving our problem. First, our system model initiates with vehicles on the road communicating with one another. All vehicles will require an LC, which stands for Location Certificate, to approve their position simultaneously. An LC is offered by an RSU, which acts as a proof of location for vehicles, which helps to find the event messages in a given geographical area. The problems of scalability and time in the previous blockchain become insurmountable for real-time VANET application. Here, the events are local and event messages are confined to vehicles found within a specific geographical area. In the classical blockchain, the newly minted block is broadcasted universally, but the VANET messages do not cross the boundary of a specific location. Since the traffic and accident details of a location are unknown to vehicles found in another location, hence the clustering algorithm is introduced and executed to cluster the vehicles, and then cluster heads are elected. Then the packets sent via any vehicle will be checked by a machine learning algorithm to detect if there are any type of attacks. Afterwards, the intra-cluster, and other communications among the vehicles takes place via blockchain technology. Our system can be tested in several ways. Here we have two examples. First, the network simulator. It is a free software which is targeted primarily for research and educational use. Network Simulator is a discrete event for Internet systems, publicly available for research, development, and simulation. It's also licensed under the GNU GPL v2 license. Another way of system testing is SOMO, which stands for Simulation of Urban Mobility. SOMO has been used within several projects for answering a large variety of research questions. And these are some of these projects. For example, calculation of emissions, AI training for traffic light plans, simulation of the traffic effects, and many other projects.
Now we are working in parallel in two teams. First team started with data analysis, feature selection, pre-processing, and now writing model algorithm. Second team started with business analysis and system model and now in building the network. Our project will solve many problems and has social impact as it will save time for drivers, reduce risk and attacks, and reduce accidents. Thank you.